Students, we are talking about the twisted pair cable, the first type of the guided media, and we discussed the further subtypes of a twisted pair cable. The first one was unshielded twisted pair, or UTP, and the second one was shielded twisted pair, or STP. Students, once again, as you can see in the slide, the only difference between the two is that in the case of shielded twisted pair, we have got a metal shield that protects the two twisted conductors, and that allows us to prevent the penetration of noise in this twisted pair. Students, there is some categorization that the EIA, or the Electronic Industries Association, they have developed, and based on that, we have got certain standards, and those standards actually classify our unshielded twisted pair. And they not only give us these standards, but they also specify the individual uses and the corresponding data rates. Students, as you can see on the slide, we have got different categories, and these categories are given by Cat 1, Cat 2, Cat 3, Cat 4. Normally, what we use today is Cat 5 and Cat 6 for most of our local area network or LAN data communication implementations, but you also have some shielded screen twisted pair cable as well, and the data rates are humongous for this. Cat 7 actually carries up to 600 megabits per second. Students, let's talk about the two categories in here that are mostly used. The first one is Cat 5, or category 5, and this cable wire, it's normally the gauge or the size of the copper conductor is 24 AWG. AWG is the unit of your gauge or the conductor size, and it's got a jacket and outside heath. So this outside heath or heath, depending upon how you want to pronounce it, it can carry a data rate of up to 100 megabits per second, more than enough for our data communication local area applications. Then you've got a category 5E. Let's talk about that as well. It's an extension to Cat 5, and it includes some extra features to minimize the noise. So there is some extra manufacturing features that are built in to minimize the crosstalk and electromagnetic interference, and for that particular reason, we are able to increase our data rate from up to 100 megabits per second up to 125 megabits per second. Once again, the major application is local area networks in this case. And students, then we have got the Cat 6, which is probably the most common UTP cable that we use in today's datacom applications. And the data rates possible are 200 megabits per second, and once again, it's used in the local area network environment. Students, the thing to note in this particular case is that the categories are determined by cable quality. So the quality of that cable and what kind of manufacturing features are you building into that cable, that defines or decides on how much data rate, max data rate is possible. These data rates, by the way, are maximum. It's not necessary that a Cat 6 will guarantee a data rate, for example, of 200 megabits per second, because the actual data rate that can be carried through a twisted pair cable, a UTP cable, that depends on quite a few other factors like noise, interference, crosstalk, and so on. Students, कुछ बात करेंगे UTP connectors की. हमारे पास the most common UTP connectors that we have got, they are the RJ45 connectors. I'm pretty sure most of you have heard about them before. And these, the RJ stands for resistor jack, so I'll write it out here. You are probably familiar with RJ, but I can bet not a lot of you would know what does RJ stand for. So RJ is called resistor jack, and the RJ is a keyed connector, students. So what is a keyed connector? A keyed connector is the one which can only be inserted in one way. You cannot flip that connector. So in this particular case, we have got a female and the RJ45 male that can only be used using the 8 pins in that connector in the configuration that you are looking at on your screen in one single way. Students, कुछ बात करेंगे about the performance of UTP. And when you're talking about the performance of a guided media, a very good gauge is normally to have a graph between attenuation and the frequency. So the frequencies that it can carry versus the attenuation that it experiences. Students, when we draw a graph between different gauges or diameters in inches, so basically you can see I told you that a gauge is nothing but the size of your conductor. So in this particular case, it's represented by the diameter. Gauge 18 would have a diameter of 0.0403 inches, and so on. Your gauge 26 is 0.0159. Students, let's look at a frequency of 1000 kilohertz. And as you can see, at 1000 kilohertz, your attenuation actually goes up, and it's pretty constant. You don't have a real exponential rise in attenuation with the increase of frequency. But as you can see, the lowest gauge has got lesser attenuation. Your higher gauge, as you go high, the attenuation also increases with the frequency. And at approximately 1000 kilohertz, you have got the highest attenuation, which is approximately equal to 20 decibels per kilometer. Students, in terms of applications, our normal applications are for this particular twisted pair cables. They are used in telephone lines, as you know already, and they carry voice, they carry data, local loops. We use these twisted pair for local loops as well. And the most important one today in terms of data communication is DSLs. So our digital subscriber line, and we'll talk about that in the upcoming topics. The DSL technology uses twisted pair cables, pretty much completely when we talk about the connectivity of digital subscriber line to our residential premises.